Last time when I spoke about testing, I went straight to the meat with the TDD in React. Now I want to take a step back and talk about the basics, from the purpose of testing through setting up environment to writing basic tests and eventually in the future creating full suites. This video is aimed at people who want to learn how to test JavaScript applications or have questions regarding the matter or simply need a refresher. Hi, my name is Tomasz and I'm a former tech lead and manager. Today I will show you how to test JavaScript applications. In today's development landscape, writing tests is a crucial skill. But before we dive into how, let's talk about the why. When you create something, anything like a calculator or a to-do app, you need to see if it works. You can do it quickly by running it and clicking around. But doing this every few seconds when you change something is just tedious. And once you're done working on one part, on one functionality, you will move further, right? But how to make sure that what you're doing won't break anything somewhere else? You can manually test every change, but it's boring, time and energy consuming. You can instead write a test to check it for you. Tests are usually divided in three groups: unit tests, integration tests, and end-to-end tests. Unit tests are the smallest ones, the easiest to run, the easiest to write. They check one functionality in one component. For example, if this button can be clicked, or is this function returns what I wanted to return. Integration tests are bigger and they check how components integrate with each other. For example, if clicking this button will make the data fetch. So it checks whether clicking in one component will trigger an action in another component, and then whether this action will result in rendering something in yet another one. So it checks how it integrates together. And there are end-to-end tests, which are the hardest to write. They take the longest time to create and to run. They kind of simulate user behavior. So they spawn the browser and click around, or they create an API requests that are basically thrown against your API. There are tons of testing pyramids out there, but the gist is first the unit tests, then the integration ones, then E2E. It goes from the cheapest to the most expensive. But what does it mean, cheap and expensive tests? We live mostly in capitalism. Everything's bottom line has assigned a monetary cost. Your time, your computer's power consumption, your remote environment working time, like working minutes, you have build time on every cloud provider. We can say the test is cheap if writing it takes only a few minutes and executing it takes roughly 1 millisecond. It's just that fast. If it can be written very fast and run very fast, it is cheap because it won't cost much to do so. Of course, everything relies on what you are testing. If you are testing a pure function, it would be easy. If you are testing something bigger, like aforementioned API call, components that rely on each other, this will take more time to write. It will most likely require some preparation, like preparation of the data you want to mock, and this won't be fast to write, and it will take more time to execute. This test will be more expensive as it will cost more of your time and cost more of computing power. And there are end-to-ends which are the most expensive because, as mentioned before, they emulate user behavior. So for example, if you have an input text, they won't just paste the content and move along. They will try to type, so they will insert one letter after the other. This takes a lot of time, and sometimes end-to-end tests take several minutes to complete. They work best as full suits, so you can test the entire feature, the entire flow, in the entire path in one test. But as mentioned, they are the most expensive ones. All right, theory out of the way, we can move into practice. We won't be building a large project here, as I want this to be easy to comprehend. We will make a simple sum function so that after submitting two numbers, it returns their sum. Nothing fancy. So let's jump into the code and see how it goes. Right, so let's initialize the project by creating an empty vid. Create vid at latest empty vanilla project. Template vanilla. Create vid latest template vanilla, right? And JS testing 101. Okay, so npm install. And while we are at it, let's also add vtest -d, because this is a development dependency. We won't be using this in the production, right? We won't ship this to our customers. So vtest. Okay, and see you in the IDE. All right, so we are here in the IDE, and what we want to do is to write a function and then write tests for it. So as I've mentioned, we will be writing a function that will add two numbers and return the sum of it. So let's create a file that will do just that. Source sum/sum.js. And what this function should do, so function sum, a and b, exactly. It will take two parameters, a and b, which are both numbers, and will return a number. Right. So this is the implementation of our function. Now the tests. The three elements of tests are preparation, execution, and expectation. So what can we do to prepare this test? Well, for the first thing to do is to export this function so it will be visible to other files. Now we are creating new file sum.test.js. This is important to have .test.js or .test.ts or whatever, because this will be picked by the test runner. So if you name this just some testing or something like this, it won't be picked up. But if it will be named properly, everything will be fine. First thing, we import sum from sum. And writing tests can be twofold. We can create a test suite that will have description and assertions in there, or we can create a standalone test. For now, for today, I opt for the second option. So we are writing test, and in here we say what we want the test to do. So adds to 2 and 2, right? And now we are writing the function, the test implementation. So what we want execution first, right? So result will be a sum of 2 and 2, yeah. And now expectation. Expectation will be expect, because we are expecting. This is the function that is exposed. So expect result to be or to equal, doesn't really matter in this case, 4. Okay. What we need to do as well is to import test and expect from vtest because these are not globally exported at this moment. We can add this and we can configure this in vit configuration, but to keep this simple, I am not doing this. Okay, so we have this. So how do we run this? Well, in the terminal, we just type vtest. And as you can see, it found the test.js. It executed one test and it provided, because this is the only test it found, so it provides the whole information. So how many test files and how many tests have passed. And if we would have a failure, it would also say that number of tests failed. You can see the duration here, which has transform, which has preparation, which has all of those things, but the tests themselves took only 1 millisecond. This is a rough estimate, so it might be like 1.2 milliseconds or 0.9, but the gist is this is a pretty performant, pretty fast test. So as you may notice, this has waiting for file changes. This means if we will create more text in here, it will rerun. You see, it was in here we have times 1. So this means it was rerun 1 time. So we can create another test, add 3 and 3. And if I'm not mistaken, sorry, result is some. If I'm not mistaken, the result should be 6. Yes. So we are summing two things and we are expecting the result to be this. And as you can see, it added it has a second rerun and it added this test, and now we have 2 tests passed. But if we change this to 5, we will get a failure. We will get information that 1 test failed and 1 test passed. And in here we will got the information what went wrong. So it says assertion error. So we did wrong. We put wrong expectations. Like we expected the wrong thing. Let's call it that way. So we are expecting 6 to equal 5. This 5. And it says that we expected 5 in here in the green text and received in the red text is 6. So, this says that you made wrong assertion, wrong assumption, wrong expectations. So going back to 6 works perfectly. And you can add a lot of tests in here, but the gist is that the best thing about tests is the fact that we can change the function implementation without touching the tests. And this is basically an indication that your test is decent, it's good. Because if you can change something in here, like we can do this, and our test will now fail, right? Because 3 times 3 is 9. So obviously, but we can refactor this because let's say we want this to be more complex because we like to show off, right? So we can say that, okay, I will take, because this is a full function, right? So it has arguments, variable available inside. And we can go through every element in there and sum it up. So let's try to do this. Let sum equals 0, and arguments are in a form of object. So arguments are like, hold on, yeah, exactly. For 2 and 2, it will be object with a string of key 0 will be 2. Element with a key string 1 will be also 2. So what we want is we want only the values, right? So we can go with args equals object dot values of arguments. This will give us an array of 2 and 2, exactly. So now we can simply write a for loop and return the sum. This can be done via for loop, via for each loop, via object reduce. This is all, sorry, array reduce. This can be done in various ways, but the good thing is we've changed our implementation of the function. We didn't touch the test and they are still passing. So this means the test is low maintenance and by this inexpensive and does its thing. So we are changing this, but we are not changing the test and we are still getting the validation whether our code still works. We can also expand this to some more elements. For example, like this, right? And now it will accept more than two elements. So this 3, 3, and 3. Sorry. And the result, and it also works. So in here we've had a spread operator. And note that this changed the function signature because the previous, the previous function signature was like this, number, to number. And now we have something like, sorry, number to number. So in the infinite number of numbers, I'm sorry. So this can be treated as an extension of the function. It doesn't break this this notation, this signature. So if you remember from solid principles, there is a principle that means locked for modifications but open for expansion, something like this. I don't really remember. But this means we cannot alter the base functionality of a function, but we can expand it. So this way, we also made our function a bit more complex because it now accepts these parameters as an undefined number of parameters. It can be 1, it can be 100. But we still haven't changed that it works in the first place. So the initial implementation still is correct. This is very important when you are refactoring your code. If you want to expand this, having tests is basically a godsend because you can verify whether it is working from the get-go. You don't need to, change anything. But this is this is important to not change the tests. So we have our function, hold on. We have our function, we have our test, and everything works perfectly. I hope you found this useful. This is just an introduction to our longer testing course, and I will continue with testing more complex code, mocking API responses, and testing the entire app in the next parts. Thank you for watching. Happy testing and happy coding.